Hello everyone, today we are starting your unit 2 and the topic is multiplexing. Multiplexing is the process of simultaneous transmission of two or more individual signal over a single communication channel. Due to multiplexing, it is possible to increase the number of communication channels so that more information can be transmitted. The typical application of multiplexings are in the telemetry and telephony or in the satellite communication. The concept of simple multiplexer is shown in the figure. The multiplexer receives a large number of different input signals. The multiplexer has only one output which is connected to the single communication channel. The multiplexer combines all input signals into the single composite signal and transmit it over the communication medium. Sometimes all the composite signals is used for the modulating a carrier before transmission. At the receiving end, a common link, a demultiplexer is used to separate out the signal into their original form. The operation of demultiplexer is exactly opposite to that of multiplexer. Demultiplexing process is exactly opposite to that of multiplexing. Next point is types of multiplexing. The multiplexing technique can be broadly classified into two categories, namely analog multiplexers and digital multiplexers. There are three basic types of multiplexing. First is frequency division multiplexing, that is FDM. Second is wavelength division multiplexing, that is WDM. And third is time division multiplexing, that is TDM. Generally, FDM and WDM systems are used to deal with the analog information, whereas TDM systems are used to handle the digital information. In FDM, many signals are transmitted simultaneously, where each signal occupies a different frequency slot with a common bandwidth. In TDM, signals are not transmitted at the time, they are transmitted in different time slots. Now we will see types of multiplexing one by one. First is division multiplexing, FDM. The operation of FDM is based on the sharing the available bandwidth of the communication channel among the signals to be transmitted. That means many signals are transmitted simultaneously with each signal occupying a different frequency slot with the total available bandwidth. Each signal to be transmitted modulates and different carrier. The modulation can be AM, SSB, FM or PM. The modulated signals are then added together to form a composite signal which is transmitted over the single channel. The spectrum of composite FDM is shown in the figure. The general form of the FDM systems are used for the multiplexing the analog signal. The applications of FDMs are telephone system, AM that is amplitude modulation and FM that is frequency modulation, radio broadcasting. Third is TV broadcasting. Fourth is first generation cellular phone used FDM. Advantages of FDM. A large number of signals or channels can be transmitted simultaneously. FDM does not need synchronization between the transmitter and receiver for proper operation. Third is demodulation of FDM is easy. And fourth is due to slow and narrow band fading, only a single channel gets affected. Disadvantages of FDM. The communication channel must have a very large bandwidth. Intermodulation distortion takes place. Large number of modulators and filters are required. FDM suffers from the problem of crosstalk. All FDM channels gets affected due to wideband fading. Now we will see the multiplexing process of FDM, that is FDM transmitter. The figure shows the block diagram of the FDM transmitter. The signal which are to be multiplexed with each modulate a separate carrier. The types of modulations can be AM, SSB, FM or PM. The modulated signals are then added together to form a complex signal which is transmitted over a single channel. The operation of FDM transmitter is first, each signal modulate a separate carrier. The modulator output will contain the sideband of the corresponding signal. The modulator output are added together in a linear mixer or adder. The linear mixer is different from the normal mixer. Here the sum and difference frequency components are not produced, but only algebraic addition of the modulator's output will take place. Different signals are thus added together in the time domain but have their own separate identity in frequency domain. The composite signals at the output mixer is transmitted over the single communication channel, and these signals can be used to modulate a radio transmitter in FDM signal is to be transmitted through the air. Next is demultiplexing process, that is FDM receiver. The block diagram of FDM receiver is shown in the figure. The composite signal applied to the group band pass filter, that is BPF. Each BPF has a center frequency corresponding to one of the carrier used in the transmitter. The BPF have an adequate bandwidth to pass all channel information without any distortion. Each filters will pass through only its channel and reject all other channels. Thus, all the multiplex channels are separated out. The channel demodulator then removes the carrier and recovers the original signal back. Next is wavelength division multiplexing, that is WDM. WDM is the variation of FDM. It is specifically used for the fiber optics channel. As shown in the figure, fiber comes together at the prism at the each having energy in the different frequency band. After passing through the prism, beams are combined onto a single shared fiber for transmission to the distant destination, which they split again. Channels having different frequency ranges can be multiplexed on a single long fiber. The only difference between WDM and electrical FDM is that optical system is completely passive and thus highly reliable. Reason of WDM is popular is that the energy on the single fiber is low or few gigahertz wide because it is impossible to convert between electrical and optical media any faster. Since bandwidth of the single fiber band is about 25,000 gigahertz, there is a great potential for the multiplexing many optical channels together over a long route. Necessary condition is that incoming channel use different frequency band. Potential application of WDM is FTTC, that is fiber to the curb system, or in the SONET network. We fix we have a fixed wavelength bits from the fiber 1 to fiber 3 and fiber 1 to fiber 2, that is source 1 to source 3 and source 1 to source 3. It is not possible to have bits going from fiber 1 to fiber 3. It is also possible to build WDM system that are switched which contains many input and output fiber switching data among themselves. Although spreading energy over n output dilutes by n factor, such systems are practical hundreds of channels. If light from the one of the incoming fiber have to go to any output fiber, all output fibers need to tunnelable filters. Alternatively, input fibers could be tunnelable and output one fixed. Having both to be tunnelable is unnecessary expense. Simple block of WDM transmitter and receiver is shown in the figure. Applications of WDM. One important application of WDM is SONET network, in which large number of network of optical fiber lines are multiplexed and demultiplexed. DWDM. The long form of DWDM is dense wavelength division multiplexing. It can be multiplex a very large number of channels. The spacing between adjacent channel is small. Efficiently, DWDM is higher than WDM. Next point is time division multiplexing. The process called multiplexing is used in order to utilize a common transmission channel or medium to transmit more than one signal simultaneously. TDM is the digital multiplexing process. In TDM, all the signals to be transmitted are not transmitted simultaneously. Instead, they are transmitted one by one. Thus, each signal will transmit for a very short time. One cycle of frame is said to be complete when all signals are transmitted once on the transmission channel. The TDM principle is shown in the figure. As shown in the figure, one transmission of each channel completes one cycle of operation is called frame. The TDM system can be used to multiplex analog or digital signal. However, it is more suitable for digital signal multiplexing. The TDM concept will be more clear if you refer the below diagram. The data flow of each source, that is sender 1, sender 2 or sender n, is divided into units, that is 1, 2, 3 and n. Then one unit of each source is taken to combine to form a one frame. The size of each unit as 1, 2 can be 1 bit or the several bits. The frames of TDM signals are shown in the data flow in the figure. For the 3 input being multiplex, a frame of TDM will consist of 3 units, that is unit from each source. Similarly, for the number of inputs, each TDM frame will consist of n units. The TDM signal in the form of, for the frame is transmitted on the common communication medium. One most important concept in TDM is data rate. For TDM, the data rate of the multiplex signal is always n times of the data rate of individual source, where n is the number of source. So if 3 signals or sources are being multiplexed, then data rate of the TDM will be 3 times higher than the individual data rate. Naturally, the duration of every unit, that is 1 or 2 in TDM signal, is n times shorter than the unit duration before the multiplexing. Applications of TDM: multiplexing of digital signal, digital telephony, satellite communication, fiber optic communication, wireless application. Advantages of TDM: full available channel bandwidth can be utilized for each channel. Intermodulation distortion is absent. TDM circuitry is not very complex. The problem of crosstalk is not severe. Disadvantage of TDM: synchronization is essential for the proper operation, and due to slow narrowband fading, all TDM channels may get wiped out. Thank you.